Hi, I'm Camille Gobert, a French PhD student from Paris-Saclay University. In this talk, I'm going to present the work Michel, Beaudouin-Lafon and I did to better understand and support users of LaTeX, a powerful document description language. In a traditional LaTeX editor such as Overleaf, modifying certain parts of the document, such as a mathematical formula, can be slow and cumbersome. Some editors enable to locate the approximate position of the code of an element, but the user remains responsible of locating the exact piece of code to modify, interpret its content, and make the necessary changes by editing everything as text. We interviewed 11 users of LaTeX to better understand their problems and their needs. We analyzed the results with a thematic analysis and generated 5 themes. They highlight that editing the code directly has benefits, such as reusing and generating code. LaTeX users struggle learning the language and forget macro names and parameters. Plain text is not appropriate to describe structures, such as tables and subfigures. Dimensions and positions are hard to visualize and to formalize, and having to recompile and to map regions of the PDF with fragments of code slows users down. Based on our findings, we formulate 4 recommendations for designing better LaTeX editors. First, give access to the code to ensure the user interface does not limit the expressive power of LaTeX. Second, facilitate specific and common actions instead of providing generic help features only. Third, enable to visualize certain abstractions, such as length and structured content. Fourth, reinforce links between the code and the PDF to assist users in alternating between one another. In light of our findings, we defined the concept of transitional representation, or transitional for short. In a document description language such as LaTeX, the source code must be compiled to generate an output document so that different fragments of code generate different elements. Transitionals are more appropriate representations of some of these fragments of code. They can be displayed by interacting with the element they generated in the output, and they can be manipulated to update the code they represent, or conversely. Transitionals are related to systems such as Sketch and Sketch, MAJ, and Livelets, with 4 key properties that both relate and distinguish them from these systems. They represent local fragments of code as a particular concept, they are bidirectionally linked to the code they represent, they persist and remain available when the code of the document is modified, and they can be displayed from and within the output they are embedded in. We applied the concept of transitional representation to LaTeX by developing i-LaTeX, a prototypal LaTeX editor with 4 kinds of transitionals. i-LaTeX lets users locate and edit the code of a mathematical formula with a live preview. The code of individual symbols or groups of symbols can be identified by pointing them with the mouse, and it can be selected by clicking them. Modifying the code updates the formula in real time, and the visualization warns the user in case of error. When the transitional representation is closed, the document is saved and recompiled automatically. The code visualized in a transitional representation can be displayed in the code editor by clicking on the title bar. In addition, since the code and the transitional are bidirectionally synchronized, the user can also edit the code in the code editor, and the transitional will be updated to reflect the changes in real time. i-LaTeX lets users visualize the structure of a table as a grid and edit its content. The content of the table is displayed within the cells and can be edited as text. New rows and columns can be inserted anywhere with the help of a contextual menu, and they can also be deleted. In addition, rows and columns can be drag and drop to reorder the grid of the table. i-LaTeX lets users manipulate certain parameters of an image interactively. Images can be resized, including when their dimensions are specified with variable length units such as \text width. They can also be cropped by selecting the region to display, which will update the trim and clip parameters of the command. Finally, i-LaTeX lets users manipulate grid layouts. These layouts are made of rows of cells that can contain arbitrary content such as text, tables, and images. They have been developed specifically to be manipulated with i-LaTeX, but the code is compatible with any other editor. Cells and rows can be resized interactively by dragging the separators between them. New cells can be inserted or deleted by clicking the appropriate buttons, and existing cells can be dragged to a new position. The content of every cell can be selected by clicking on it so that it can be edited directly in the code editor. We used i-LaTeX to conduct a controlled experiment with 16 participants to evaluate the effect of transitional representations on common editing tasks in LaTeX documents. We compared two conditions, having access to the code editor and to the transitionals in blue, and only having access to the code editor in orange. In each condition, participants had to perform 9 editing tasks in a set of LaTeX documents. The tasks included 3 tasks with mathematics, such as changing a symbol in a formula, 3 tasks with tables, such as editing a few cells in a table, and 3 tasks with images, such as resizing an image to match the width of another element. In addition, we also asked participants to fill in questionnaires to estimate and compare the workload of each condition. The order of the 2 conditions and the 2 document sets were counterbalanced across participants, resulting in 4 experimental configurations. The results show that with access to transitionals, participants completed tasks with tables 42% faster and tasks with images 58% faster. While the difference is not as pronounced for tasks with mathematics, transitionals still benefited the least efficient participants who completed them 28% faster. In addition, with access to transitionals, participants compiled code of table 26% less often and code of images 58% less often. Almost all participants reported that using transitional was less mentally demanding, less temporally demanding, less frustrating, and enabled them to achieve better performance. We also observed the difference between the 2 conditions in terms of strategies used by the participants. When they only had access to the code editor, several participants spent minutes trying to come up with elaborate, exact solutions, but often failed at implementing them and eventually resolved to simpler alternatives. When they had access to transitionals, participants immediately favored approximations and straightforward solutions, which helped them solve tasks faster. We proposed 3 directions for future work on this topic. The robustness of i-LaTeX could be improved to support a broader range of LaTeX documents, and new transitionals could be added for other kinds of content. Transitionals could be implemented in existing LaTeX editors such as Overleaf, therefore making transitional more accessible to LaTeX users and facilitating user studies in more ecological settings. Finally, transitionals could also be applied to other document description languages such as Markdown and HTML, CSS to supplement existing tools such as code generators for tables and style. You can find more information about this work in the paper, and you can contact us if you have any questions.